Hello everyone. Today I will be presenting a detailed solution to a practice problem regarding Markowitz portfolio selection model. This problem is from our coursework, which explores how we can mathematically determine the most efficient way to allocate wealth between risky assets to balance return and risk. Let's look at our market setup. We are considering a market with two risky assets. Asset 1 has an expected return of 1, while asset 2 has an expected return of 2. We are also provided with the covariance matrix, where the variance of asset 1 is 3 and asset 2 is 5, with a positive covariance of 3 between them. Later, we will also introduce a risk-free asset with a return of 0.1 to see how it shifts our investment frontier. Our first task is to find the efficient portfolio weights, denoted as as X star, based on the risk tolerance parameter tau. To do this, we first calculate the inverse of our covariance matrix B. After finding the determinant is 6, we derive the inverse matrix W. Following the Markowitz theorem, the optimal portfolio is a combination of the minimum variance portfolio and a risk rating adjustment. By plugging in our values, we find that the optimal weight for asset 2 is tau by 4, and the remainder of our wealth, 1 minus tau by 4, is invested in asset 1. Once we have our weights, we can calculate the expected return and variance of the portfolio. The expected return, mu tau, is a linear function of our risk tolerance, 1 plus tau by 4. The variance, sigma tau squared, however, grows quadratically as we increase our risk tolerance, following the formula 3 plus tau squared by 8. This perfectly illustrates the fundamental trade-off. To get more return, we must accept a disproportionately higher level of risk. Now, by isolating tau in our return equation and substituting it back into our variance equation, we can derive the direct relationship between risk and return. This gives us the equation of the efficient frontier, which is sigma square is equal to 2 mu square minus 4 mu plus 5. In a graph where we plot standard deviation against return, this forms a hyperbola. The efficient part is the upper branch of this curve. Notably, the minimum variance portfolio, which is the point with the absolute lowest risk, occurs when the return is 1 and the standard deviation is the square root of 3. Finally, we introduce a risk-free asset with a return of 0.1. When we combine a risk-free asset with our risky hyperbola, the efficient frontier changes from a curve into a straight line, known as the capital market line. This line starts at the risk-free rate on the y-axis and runs tangent to our hyperbola. The point of tangency is the tangency portfolio. In this specific case, we calculated a Sharpe ratio of 0.77, which represents the excess return we earn per unit of risk. This completes our analysis of how an investor can move from a simple diversification to a mathematically optimized portfolio. Thank you very much.